Ladies and gentlemen, hello, I'm Yaseri Dahlia Apritasari from Agung Podomoro University. I would like to present my paper with the title Optimization of Heat Gain in Vertical Housing Design for Middle-Low Economy, Cengkareng, Jakarta Barat, using Rhino, Grasshopper, and Ladybug simulation. My team, Hari Marvin Kristanto, Ibu Beta Paramita from Universitas Pendidikan Indonesia, and Ibu Maria Prihadrijanti. Actually, this research is part of Building Performance Simulation Research Program from Universitas Pendidikan Indonesia. I would like to present the introduction. Jakarta is a metropolitan city that has specific problems: high urbanization, increasing 4% per year, start from 2010 until 2020, data from BPS, have high density, limited environmental carrying capacity, urban environmental degradation, and limited housing land in urban area. High urbanization and high housing needs result in the growth of slum housing in urban area, we call urban kampung. Urban kampung with the current condition don't meet the quality of life and also don't meet thermal comfort. We can see the picture, the left side, urban kampung housing condition in Cengkareng, Jakarta, Jakarta Barat, have high density, slum area, limited facility, irregular housing building shape, not meet life quality. We know that in urban kampung, to meet thermal comfort through the passive design. And then alternative housing of urban kampung solution with a vertical housing design strategy by taking into account thermal comfort, optimization, heat gain, and livable good quality of life. And the purpose, we have two. The first one, to identify the urban kampung housing structure and to interpret it into a vertical model for housing middle low risk cost. And the second, to make a computational simulation model to produce an optimal design to minimize the gain of solar radiation. We use Grasshopper, Ladybug, and the Rhino. You can see the picture, the right side. The first one is about kampung condition, and when interpret the condition, and we divided the basic form, and from the basic form, type 27, type 36, and type 42, we explore to make many geometric composition, solid and void. And below, we can see the result of the building from the simulation. Research methodology divided to 4 steps. The first one, to analyze microclimate and site condition on Kampung Kota Cengkareng. The second, to make model design simulation of vertical housing based on the site and microclimate. The third, to analyze of simulation result and design optimization. And the fourth, to give recommendation for optimizing design efficient. We can see the experimental setup. The first, kampung structure interpretation from composition solid versus void. Actually, solid is the housing, void is the road or the open space or the playground or the green area. And then we identify the basic form. And then from the basic form, we did simulation, we did explore modular massa with a bend 90 degree to get different view. And the result, model 1, model 2, model 3. The 3 model respond from the kampung structure and a microclimate and a context condition. And we do simulation with the model geometry through math model, rhinoceros, and then a visual programming simulation through algorithmic grasshopper, and the last climate visualization and analysis through Ladybug. And the final recommendation for optimizing design acquisition. From the first one, microclimate and site condition. We can see the site condition, location of dense urban kampung housing, and the location of vertical housing sites in red area. The red area is the vertical housing plan proposed. Now we can see the condition of the kampung, slum, limited facility, irregular housing building shape. We can see small path, or we can see gang is the can encourage wind corridor. And from the left side, we can see climate condition, thermal comfort, relative humidity, thermal stress, outdoor comfort, and wind data. From the first one, microclimate, we move to geometry models and optimization of heat gain in building. We start from kampung structure and the basic form, and we explore and made composition of solid void geometry. For the model one, the shape responds to site condition and solid void geometry mass composition by forming 3 blocks. Each block has an open space void. Orientation on east and west side. The line shape are expected to give each other a shadow and reduce heat gain. For the second building, by forming 3 blocks. Each block has open space void, long plane facade orientation, the north and south side. The south facade of the east and west is expected to reduce heat gain. And the third is different with the model 1 and model 2. The mass shape are put together and with large void. The shape of the building mass is made of paradox between floor, and so that the shadow formed between the geometric shape of each floor. And the next analysis, heat gain vertical housing, analysis for solar radiation, radiation direction, UV exposure, sun movement, wind direction, and ventilation system. And then we can see the model 3 get lowest solar radiation, get lowest radiation direction, and we can see from the ventilation system and from wind direction, UV exposure, and sun movement, the 3 model get the same optimized the form and model. We move to supporting design factor. It's about geometric composition and circulation, natural lighting, outside view analysis. The geometric composition of the building with solid and void arrangement design to give the impression of solid void urban kampung structure. Actually, the 3 model already respond the solid void urban kampung structure. And the circulation access is adjusted to set condition or context. The third massa form allow exploration of more detailed design to minimize solar radiation, shadowing between floor layers, and reduce the gain solar radiation. The most effective in getting sunlight is model 3. We can see model 3 is more effective, get sunlight. And then we can see outside view analysis, model 3 get the highest outside view analysis, about 80 until 90%. The final design, we can see the last of the model 3, we can explore more detail. And then we can see vertical arrangement with difference its module arranged paradoxically, resulting in shading that reduce solar radiation gain. And for the natural ventilation resulting from the voids formed and each floor stack effect ventilation. And the last, this is about the final design. And for conclusion, the interpretation of the solid void urban kampung structure so that response of to climate condition, paying attention the orientation to minimizing facade, west and east orientation to minimizing the acquisition of solar radiation. The second, the paradoxical shape between the floor layers create a canopy that shadows each other between geometric shape to reduce solar radiation gain. The third, exploration of geometry shape to optimize solar radiation and heat gain with rhinoceros, grasshopper, and ladybug simulation can be done by making various models. The simulation greatly help predict more efficient design, optimize passive cooling, and save energy. Along with the development of vertical housing in urban area, the simulation model will improve design decision and for low-cost vertical housing. Acknowledgement, and then the reference. Thank you very much.